Now, what are we asking in multivariate analysis? What we really want to know is when we control for the significant covariate variables, right, the other variables that are related to the pretest to post-test happiness score change, which are education and income level. When we control for their effect in the pretest to post-test change, what is the effect of the independent variable, which is study group, right? So really what we want to know is, does study group explain the pretest to post-test change in happiness, over and above the covariate variables? I mean, it could be. So if somebody got a raise and if they have a high income because they're continually getting raises, that could be responsible for their changes in happiness from pretest to post-test. So we want to make sure it's the study group, right? Not something outside the study. All right. So again, we're going to look at the use of multiple linear regression, MLR, and repeated measures, GLM. And it'll be A-OK. So just a little cautionary warning here. Remember, whenever we do multiple linear regression or any regression model, we need to have variables that are either continuous or dichotomous. Dichotomous meaning categorical with two categories. So if we have a categorical variable with more than two categories, such as our education level, right, which is high school, GED, college, and graduate school, three categories, we need to dummy code, right, dummy code each category within the variable for use in the regression model. So each variable becomes, so the three categories become three separate variables, each with a yes/no response. And as a reminder, that's done with the recode into different variables function in SPSS. So if we take our education level and we have our three categories, high school, GED, college, and graduate school, via dummy coding we get three dichotomous yes/no variables, right? So education level, high school, yes/no, education level, college, yes/no, and education level, graduate school, yes/no. So in the regression model, we leave one of those categories out, so that becomes the reference category. So the scores are, for the two groups included, are in reference to the one group left out, and we'll see that in our regression model. And we're going to leave out high school GED as the reference group. So again, the multivariate test key, which regression model do we need, is dependent upon the structure of the dependent variable, be it continuous, categorical with two categories, or categorical with three or more categories. And for our purposes, our dependent variable is continuous, right? So we have our pretest, post-test difference score with a possible range of -4 to +4. So because it's continuous, we're going to use linear regression. So linear regression, here is the path for linear regression. And remember, on the fourth here, are collinearity stats and a z-pres, z-resid plot. So let's look at that quickly in SPSS. So we go to our analyze, regression, linear. Then in the dependent, we put the dependent variable, pre to post change. And then the independents, right? So here are the dummy coded versions. So high school GED gets left out. The dummy code education college, the dummy coded education graduate school gets put in, as well as income and study group. So there are our predictors. Now what we were reminding us is that in plots, right, we want to choose that and put in the z-pred by z-resid, continue, and under statistics, we want to click collinearity diagnostics and continue, right? And then we paste and we run our regression model. Right? And there we have it. There's our regression model. Now let's look at the parts of the regression model, what to look at first. So the first thing we want to look at in the regression model is the small ANOVA table given. Specifically, the final column in the ANOVA table says sig, and that tells us if the whole model is statistically significant. If it's not, we don't consider anything else about the model. But it is, right? So it has to be 0.05 or below, and it's 0.000. So it's the first thing we look at. It's significant, so we go on to the next thing. So in the final column, we look at the statistical predictors, right? So we see the significance of each. So all the predictors are statistically significant, right? So if one predictor wasn't significant, we would not consider its effect, but they're all significant, so we're considering the effects of each predictor. So in terms of the reference group, don't forget, so college is significant and graduate school, education, graduate school is significant. So what that's saying is there, for college, for example, that there's a significantly higher increase in pretest to post-test scores in reference to the high school group, right? And the same with graduate school. So always remember, the reference group isn't presented, but it's still in reference to them. Third, right, so if we look at the beta, we can see the directionality. So if there's a minus, right, it's a negative direction, right? So if income had a minus, for example, at the beta here, the 0.008, it would mean higher incomes are associated with lower change scores, but it's positive. So higher income level is associated with higher pretest to post-test happiness change scores. Right, and we already went over the education. Each of those is positive higher in reference to the high school group regarding change scores. And then study group, we need to know how it's coded. So experimental is coded as 1 and control is coded as 0. So that means as study group increases, in other words, from 0 to 1 or from control to experimental, there's a positive relationship with change scores, meaning that the higher value experimental group is associated with higher pretest to post-test happiness change scores. And the standardized beta tells us the strongest predictor in the model, right? So it could be study group significant, but maybe income level is the stronger predictor, right? But that's not the case. So you see that for the standardized coefficient, study group actually has 0.71. So that's the strongest predictor in the model. By far, the next strongest predictor is income, but it's nearly half of that, 0.436. So study group is the strongest predictor of pretest to post-test happiness change scores. So what does that tell us? It seems like our intervention is effective for this sample. Lastly, we want to look at the R squared. So that's going to tell us how much variance in the dependent variable, so how much to vary, the scores go up and down. What makes them go up and down? That's what we're trying to solve, right? That's the variance. So how much of the variance, right? There's 100% of the variance and there's 0%. So what percentage is explained by the predictors in the model? Now the R squared here is 0.827, so rounded to 0.83. So 83% of the variance in the pretest to post-test change scores is explained by the 3 variables in our regression model, which is a very high, so this is also an effect size. It's a very high effect size and a very high percentage of variance explained. Typically, 40%, 50% is high, so this is very high. So notice we didn't get an effect size in our regression model for the individual predictors. If we want an effect size for the individual predictors, we can compute the partial eta squared in an ANCOVA, right, which is simple. Here are the directions. So if we were to do that in SPSS, analyze, then general linear model, univariate, so independent variable, we have our difference scores. Now our fixed factor, that's going to be our study group, right? Our categorical fixed factor. And then the covariates, we could put education, and because we know it's structured as a continuous variable here, higher scores, higher education, we could put it in covariates, and also income level. Then under options, we can click descriptive statistics and effect size estimates. Continue, paste, right? And then we can run that. Right? And this is what we get. Whoop. There we go. This is what we get, and that's also on our slides. So you can see in the ANCOVA printout, again, the effect size, the partial eta squared for study group, is 0.74, right? So it's a very large effect size. So you can see for the partial eta squared in an ANOVA at the bottom of the slide, large is 0.14. So 0.74 is considerably large. So there's our effect size. Now, please recall, we also wanted to use repeated measures GLM, right, as our multivariate analysis tool. So if you don't want to use the multiple linear regression at this point, instead of the regression model, you could use the GLM model. And if you only have, and we'll go over this again, but if you only have one group, like you don't have experimental control, it's just one group from pretest to posttest, the GLM is definitely preferred. So we'll look how to use this. So all the test assumptions that we looked at, right? The homoscedasticity and linearity and normality, right? All that had to be looked at also, so we know we had equivalence of variances, so we could do the GLM, because the GLM is also a parametric F-test, and you need to look at those things. So basically all the bivariate up to the bivariate would be pretty much the same, just the multivariate, you would substitute the GLM for the regression model. Now again, as our iceberg example states, that's the 99% underneath. This is the 1% of the study, right? The repeated measures GLM that will actually display, the payload, the results. So here is a rather, the slide's a little busy, but this is all you need to know to do your repeated measures GLM. So rather than read it, let's do the GLM here. So we go to Analyze, then General Linear Model, and then Repeated Measures. Okay, so the first thing is number of levels. So we have pretest to posttest, that's 2 levels, so we'll put in a 2. And you don't have to name the factor, but if you want, you can. You could call it something like pre-post change with no spaces. Pre-post change. Pre-post change. Then we click add. Then we go down to the lower left and click define. So this 1 and 2 in the upper right, that's where the two levels go. So that's pretest and post-test. So now we're not worrying about the different scores anymore, right? The different scores are old news, old hat. Right, so we're putting in pretest and post-test. Then the between subjects factor, that's our study group. And like I said, if you didn't have a study group, that could be blank, but we would want to include the covariates, right? So we can put in education level and income level. Then under click option, then descriptive statistics, estimates of effect size, and observed power. Now recall when we did our power analysis, it said, we needed a certain amount of people, right? But the G power didn't accommodate for the number of covariates, right? So we can actually click observe power here to make sure if we include the covariates that our power isn't lessened to an unacceptable number, i.e. below 0.80. Then continue. Then we can paste it. Right? Then remember, we save the syntax and then we just highlight it and run it. Right now, you see here the descriptive statistics. We're going to look at that on the slide, and the multivariate tests. Now we're going to focus just on a few columns here, right, on the slide. So let's look at that. So here we go. There's the descriptives box we just pointed out. Now what are we looking at? You could see at pretest, right, the experimental and control each had a mean of 2.54. Right, so that's saying that at pretest there were not significantly higher happiness levels between the experimental and control. But at post-test, right, below here, control still at 2.54, pretty much the same, but the experimental went to 2.9. So you can see the main change was this post-test, increased post-test score within the experimental group, right? So that's our intervention effect. Now these are all those busy columns. I've extracted a few to focus upon. First, right? So first we see statistical significance. So you can see to the left here, pre-post change, right? So that's the term we named. That's just the changes in pre-test to post-test scores. So overall, they're significant. And if you only had one group, right? So if it was a single group intervention, this would be the number you're looking at. Now we're also controlling for income. So income, pre-post scores by income are also significant. The same with education level. And then also the study group, right? So they're all statistically significant. So all the predictors are related to these pre-test to post-test scores. Now, these results should also match up with the regression model, because the regression model and the GLM are both F-tests that are testing the difference in mean scores. So they should match up quite well because they're looking at the same variance pretty much. The partial eta squared. So this is our effect size, right? So we could say, again, the study group has the largest effect size, right? So it's the same as it was in the ANCOVA, right? When we were doing the linear regression model, 0.74. And then lastly, the observed power. So you can see we pretty much have 100% power for the 3 predictors, and education because it's a categorical, and remember the one category was a little lower, the 24. Right, so the power is a little low, but still pretty much 0.80, which is the acceptable level. So we have power to detect our changes from pretest to post-test by these variables. Okay, so that's it for this week. We looked at a lot, right? So next week we're going to look at the same steps 3 through 6, but for longitudinal analysis. So here, just as a things to come, here we're not in the longitudinal. We're not going to look at regression models, but we're going to look at a full exploitation of the repeated measures, GLM, and everything it could do. Okay, thank you for watching, and I'll see you next week.